In this video, I show you a neat and concise way of dealing with algebraic expressions where directed numbers are involved. But first, let's just clarify a couple of things. These symbols here, this one is sometimes used, isn't it, for addition, as in 7 add 5. Sometimes it's used to indicate the sign of a number, as in positive 3 subtract positive 4. And sometimes the word plus is used for this or this, and because it has a dual meaning, I tend to try not to use it. Likewise, this symbol, sometimes it's used for the operation subtraction, as in 7 take 5. Sometimes it's used to indicate the sign of a number, as in -2 in 3 add -2. And likewise, there's the word minus, which sometimes means subtraction, sometimes means negative. So I tend to try not to use that. So in summary, these symbols, sometimes they're for an operation, sometimes they're to indicate the sign of a number. So before we go on, you must be confident with adding, subtracting, multiplying, dividing directed numbers. If you're not, maybe you want to stop the video and address that first. Or if you want to go on, have your calculator ready so you can do any adding, subtracting, multiplying, and dividing to check my working. Now, another little idea, let's think about this. 7 take 3, obviously the answer is 4. Now, if we think about 7 add -3, 7 positives, because remember, if there's no sign associated with the number, it means it's positive. 7 positives and 3 negatives is in excess of positives of 4, so the answer to that also is 4. So these two things yield the same result, which tells us to subtract a number is the same as adding its opposite. The opposite to 3 is -3. To subtract a number is the same as adding its opposite. File that little idea away. Likewise, if you think about 5 plus -3, 5 positives and 3 negatives, excess of positives of 2, that's the correct answer. And obviously the correct answer to 5 take 3 is 2. These two things are equivalent. That tells us to add a number is the same as subtracting its opposite. The opposite to -3 is positive 3. So we can look at it this way as well. To add a number is the same as subtracting its opposite. This one we don't use so much, but let's file it away and use it in the pages coming up. Now, when teachers and textbooks explain this work, we sometimes get loose about the meaning of these symbols as to whether they're an operation or a sign. Now, we do that for a reason, because it makes it much easier to deal with these things. I'll show you that in this example. If we want to simplify this, we write the question down, and then we gather the like terms. There's a 5x here and a subtract 7x, so let's put those together. Remember, I'm looking at the sign in front of the term here. Subtract, or the operation, subtract, and then we have subtract 3 and subtract 5. Now our like terms are together. Now this is where we get a bit loose. We say 5 add -7 is -2x. That's fair enough. And we say -3 and -5. 3 negatives and 5 negatives is 8 negatives. So this is the same as -8, or we just say subtract 8. So there is the answer. Now I've been rather loose there in the way that I've used subtract or the sign, negative sign. Let's do it strictly and see what you have to do. It's much more work involved. So write the expression down again, collect our like terms, and now what you have to do is say, well, this is equal to 5x. Subtract 7 is the same as adding its opposite, which is -7. To subtract 3 is the same as adding its opposite, which is -3. To subtract 5 is the same as adding its opposite, which is -5. Now we can collect the like terms and say that 5 add -7 is -2, so it's -2x. -3 plus -5 is -8. So this is the same as adding -8. And then we use the idea that to add a number is the same as subtracting its opposite. So instead of adding -8, we'll subtract 8. And you see that we have the same answer. A lot more involved when we're strict, isn't it? So we tend not to do it that way. Likewise, these are much easier if you think loosely about the signs or the operations. This one we know we have to distribute the -2 into the bracket. So write the question down. -2 times x is -2x, nothing wrong with that. And then where did this come from? Well, we say -2 times +5 is the way we're thinking, which is -10, but we write it as subtract 10. Let's show that with really strict thinking we're going to get the same answer. Question's there. I'll explain the next line. -2 times x is -2x. Bring the operation down here, which is addition. What are we adding? We're adding -2 times +5. Negative times a positive is negative. So we're adding -10. But then to add -10 is the same as subtracting its opposite, which is 10. We've got the same answer. A bit more thought involved there, though. This one, again, to think loosely, would say it's -3 times x is well, I've written the question down again. Now, -3 times x is -3x. -3 times -4. Well, a negative times a negative is positive, so we're going to just say +12. Thinking strictly again, here's the problem. But now we have to say subtract 4 is the same as adding -4. Now, -3 times x is -3x. Add -3 times -4 is +12. And to add a positive, we can write just like that. Same answer, a bit more involved. Now this sort of expansion, let's write it down. Now this becomes x times the second bracket. Take 3 times the second bracket. And now we expand brackets like up here, x times x. I'll put it down and explain each term. X times x is x squared. X times -5, we're saying, is -5x. -3 times x is -3x. -3 times -5, a negative times a negative is a positive, and 3 5s are 15. Collect the like terms. -5 plus -3 is -8x, so it becomes x squared. Take 8x plus 15 is the neat and concise way of doing that. If you want to do it strictly using our signs and operations, here's the way it goes. There's the question, becomes this, no different. But now let's think. To subtract 5 is the same as adding -5. To subtract 3 lots of this is the same as adding -3 lots of it. And in here, to subtract 5 is the same as adding -5. So now x times x is x squared. Add, bring the operation down. X times -5 is -5x. Add, bring the operation down. -3 times x is -3x. Bring the operation down. -3 times -5, negative times a negative is positive. So it's adding positive 15. And now tidying it up. -5x plus -3x is -8x. So adding that, it's the same as adding -8x. And we haven't changed anything else. And lastly then, to add -8 is the same as subtracting 8. To add positive 15, we can write plus 15. And we get the same answer, but with a lot more effort, isn't there? So in these, we tend to be loose with our way we think about it. But if you can think that way, it's much easier and much more concise way of writing it down. So I hope that helps clarify those sorts of questions.